You are listening to Proof Text, a Glossa House podcast exploring Scripture and all things related to it. New episodes are released daily. For more information, check out glossahouse.com and subscribe to our channels on Spotify and YouTube. Welcome and enjoy.
Hello and welcome to another edition of Proselytize or Apostatize. I'm your host, David Russell, along with my co-host, David Paulman. What's up, David?
Doing great, Russell. Great to see you again. How are you doing?
I'm doing good, man. I got into a car accident last week. It was a 3-car accident, and by the grace of God, nobody was hurt. It was a wild experience. About that. Yeah, it was like 1 minute you're dropping your kid off at school, and the next minute you're down to one car. But like I said, everybody was okay. I had my little son in the car, and he thought it was just the craziest thing. The fire trucks pulled up, and he's just like, wow. And he's like, goes home and he takes these little cars and he's showing me what happened and stuff. And I'm like, man, this kid, man, he like made the whole day better. Well,
thank God for
today,
kids.
Yeah, right. Exactly. When are you going to be on that train, my friend?
I don't know. I have to find a girl who likes me first.
Okay. All right. Well, we have a very special guest with us today. I can't speak for David, but there are not enough thanks that I could give him for what he's done in my faith. He has been one of the most influential teachers of my life. Astronomer Hugh Ross is founder and president of Reasons to Believe, an organization dedicated to integrating scientific fact and biblical faith. His books include Why the Universe is the Way It Is, Hidden Treasures in the Book of Job, and Navigating Genesis. Welcome on, Hugh.
Well, thank you for inviting me.
Yeah, thanks for being here. Like I said, it's a blessing and an honor. I think the first time I heard of you, it was back in when YouTube just became a thing. I guess, I'm that old. So I'm looking up, things on young earth creationism because I was kind of in the middle there. I never was comfortable with it, but I was like, oh, I know who Ken Ham is. And you were debating him. And I was like rooting for you by the end of it because of how humble you were, Hugh. And your humility has been with me in that way. And I've kind of developed my how I debate after the humility you display and the humbleness you display to your opponents. So I thank you again for all that you've done in my faith. You've given me confidence in my faith. And we are just so blessed to have you on.
Well, thank you.
So the first thing I wanted to talk to you about was kind of just like breaking the ice. I was going to ask you what your favorite amateur telescope was.
Well, I personally own a Celestron 11-inch Ultima, and it's much more expensive than the telescope I had as a child, but it's one that I can quickly get out and do star parties with. And hey, you can actually see spiral arms of galaxies with it if you get in a dark location.
Oh, wow.
And it's fully computerized, so that can actually do star parties for 50 people without much trouble.
Yeah, what's really interesting is like when I first heard of you and started reading your books and stuff, I really related to you because I was like you when I was a kid. I loved to look at the stars, and I had to have a telescope. And my first telescope I bought in an antique shop. It was an old Jason on an EQ equatorial mount. I shouldn't say EQ. People probably won't know what that is. But it was on an equatorial mount, but it was an old Jason. I don't know if you're familiar with those old Jasons or not. Yeah, I had one of those. What is your favorite mount, by the way?
Oh, I like the alt-azimuth mount because it's actually easier for a computer to get to objects with that. The mount is a whole lot lighter, so it's more portable. You got an equatorial mount, it's about 2 to 3 times the weight to get the same stability. On the other hand, I see the value of an equatorial mount if you want to do precision photography. But for the telescope I've got, even though it's alt-azimuth, the photography is still pretty decent. But if I was into the high-end photography, I would get an equatorial mount.
Oh, nice. Yeah, the equatorial mount is kind of a pain. I'm still having trouble like lining it up right. I think I like the motion once I get it lined up, but it's really tough.
Well, like my telescope, the lineup is automatic. All I gotta do is, it's so easy. I can put it on 3 stars. I don't even have to identify the stars. The computer can figure out what those 3 stars are. And once it has that, it automatically lines up the telescope so everything's perfect. And I just tell what object it wants to go to. It's right in the center of the eyepiece.
Yeah, that's awesome.
It's incredible. The trick
Yeah.
is you have to get it perfectly level to start with. If you get it perfectly level, the computer does everything else.
Oh, wow. I'm so jealous. I wanted one, but they're just out of my price range. So
Well, you know, it's interesting because of computerization, the price has literally dropped a factor of 2. I mean, I couldn't afford the telescope I have now, say 15 years ago. But because of computerization, you can go with an alt-azimuth mount, which saves you a lot of money, saves you a lot of weight. And then the computerization means that you can actually save a lot of money on trying to get the parts in you need to sit on the objects. So
yeah, I mean,
with it.
yeah, there's just no better benefit than actually going out and looking at the stars yourself. I encourage anybody to get one. But I took my kid out there it was probably last year sometime. I have also just a regular old Tasco telescope. It's a reflector and is a refractor. Yeah, it's a refractor. And we saw the rings on Saturn for the first time with her. And it was just really cool that, you can take your kids out and show those things right in your backyard.
Yeah, I noticed kids in our neighborhood, they love watching eclipses on the surface of Jupiter.
Oh, wow.
Jupiter go by. It's a big treat for them.
Yeah, that's awesome. Well, Hugh, we have you on here because, I had some questions I wanted to ask you about the Big Bang cosmology and the new challenges that I've heard with it. I had a debate last year in which I was challenged on the Kalam and, whether the universe has a beginning or not. And I just want to know, can we still be confident that the universe had a beginning?
Well, we can be confident to the same degree that you can be confident that your son is alive, your wife is alive. I mean, after all, there is a slight mathematical possibility. You've been fooled all these years by a very sophisticated 3-dimensional hologram. But I'm sure you've done adequate experiments and observations to realize the probability of that being the manifestation of your wife and child is reasonably remote. And that's really what's going on in the community of theoretical physicists who are promoting an atheistic worldview where the universe has no beginning. They're appealing to things we can't observe and measure. And they're saying, until you can eliminate all of my atheistic speculations, I'm not going to believe in your Christian faith. Well, we humans are limited. We'll never learn everything there is to know about the universe. But what I've been documenting in the 4 editions of my book, The Creator and the Cosmos, is the more we learn about the universe, the smaller and smaller corner the atheist is backed into with their non-empirical speculations. But the very fact that all of their speculations today are based on non-empirical arguments tells you how weak their case is. But yeah, I cannot prove absolutely that there's a beginning to the universe or that God exists, but I can offer very powerful practical proof that the universe has a beginning and that there is a God, and show how that proof increases literally every week that goes by. 100% of the observations and experiments sustain the conclusion that the universe has a beginning. Can we eliminate all the theoretical speculations? No. Will we ever eliminate them all? No. But I think the powerful point is the realm of speculation has been getting squished into tinier and tinier and tinier a spot. And when I document in the 4th edition, The Creator and the Cosmos, we actually have observational tools to penetrate the quantum gravity era. I mean, that's been the birth of all these atheistic speculations, saying, well, since our measurements can't penetrate an era earlier than 10 to the minus 43 seconds, we can speculate. Well, we now actually have tools to actually penetrate that 10 to the minus 43 second brief era of the beginning of the universe, and it doesn't go well for the atheists.
Oh, wow. I didn't even know that. I mean, I guess that kind of gets rid of my next question. I was going to ask you about these supposed models like the Aguirre-Grayton and Carol Chen. Maybe if you could just speak a little bit on that with our audience, that would help.
Yeah, I can. These models are based on the assumption that in that very early era of the universe, where we lack specific observational tools, they're speculating that the quantum space-time fluctuations in that early era are so large that it opens up the possibility for loopholes around the space-time theorems. And that's what they're basing their faith that there's no beginning. However, there are ways that we can put limits on how large those quantum space-time fluctuations are. So for example, the larger those quantum space-time fluctuations, those fluctuations are going to cause the images of distant quasars and blazars to blur in proportion to the wavelength that the light travels to our telescope and how long the wavelength is, and burst to the length of the. So in other words, the shorter the wavelength and the greater the distance that we're looking at that image of the quasar or blazar, the more definitive tests we get of these quantum space-time fluctuations. Now, these observations haven't gone as far as we could go, but they show that quasars and blazars 3 billion light years away, observed at ultraviolet wavelengths, are still crystal clear sharp. There's no blurring. And so the lack of blurring tells us these quantum space-time fluctuations cannot be as large as the predominant atheistic models claim. And we could actually push it out to 12 billion light years, which would give us a more definitive constraint. We can go to X-ray wavelengths, which would give us a more definitive constraint. But so far, we've already been able to eliminate the most popular of the atheistic speculations. However, we can't eliminate them all. I mean, the atheists are basically backing up and saying, well, those models don't work, but we're going to appeal to these models. But the point is, these observations are demonstrating they're being backed into a smaller and smaller corner of the room. And, and moreover, there's a potential if we get really good images of the event horizons of black holes. Only one image has been published so far, but if we can get really good images, that will also provide constraints on what's going on in the quantum gravity era. I should also alert your listeners that there's a young Christian theoretical astrophysicist, Aaron Wall. He's published a space-time theorem, basically showing that the quantum space-time fluctuations are small. The space-time theorems hold all the way back to t equals 0, regardless of what's going on in the quantum gravity era. So, and Aaron Wall and Sean Carroll have been debating one another online. You can actually look at those debates. But you got the quantum eternity theorem from Sean Carroll, but it's based on very high quantum space-time fluctuations. Aaron Wall says if they're not as that high, then you don't escape the space-time beginning. So
I've
what's going on?
I mean, that answers a lot right there. I've read a lot of Aaron Wall stuff. I mean, this stuff always has intrigued me. I think it's probably one of my strongest things to argue as far as that goes is in apologetics. But I mean, that's awesome. I mean, I don't have anything on that. I was going to ask you about last year they changed the beginning of or the date of the age of the universe. And I was just wondering, could you speak on that a little bit?
Yeah, I've written a blog article on that. My blog is called Today's New Reason to Believe. That claim has actually been retracted by the very research group that published it. And actually, if you read the original paper, they were saying, well, based on our new research using Cepheid variable stars as the basis for the cosmic distance ladder, it looks like the universe is about 1 billion years younger than what we thought. However, there could be big systematics in the Cepheid variable stars. And about a year ago, they published a paper where they redid the whole thing, not using Cepheid variable stars, but stars are what are called at the tip of the red giant branch in the Hertzsprung-Russell diagram. And basically they said the discrepancy is gone. We're getting dates for the age of the universe that are consistent with the dates we get from the baryon acoustic oscillations and from the cosmic microwave background maps. And again, if you read their paper, they were saying our measurements are not as good as what we're getting from the cosmic microwave background maps or the baryon acoustic oscillations. But now they're showing that the measurements of the expansion of the universe up close actually is consistent. And I will also add this, and you shall see in my article, we would expect that the universe would be expanding a little bit faster in the near vicinity of the universe than the far vicinity of the universe, because dark energy causes the expansion of the universe to accelerate as the universe gets bigger and bigger. And so we would anticipate that the measurements of the expansion rate of the universe would show the universe expanding slightly slower billions of years ago, like 13 billion years ago, than it is today. And so you can read the article, but basically the measurements are now in line. They're all consistent. And the intent of that original paper was basically saying, we got systematics that we need to sort out. And now it looks like the systematics indeed are being sorted out.
Yeah. So how many Big Bang cosmologists do you think are, still, holding to the, fully extrapolated backwards model?
Model which gives a date for 13.79 billion. Is that when you're talking?
Yeah, and that there is an actual beginning. Does this vary among the community, or is it just these fringe atheist cosmologists that are just trying to find? Because I remember I heard Sean Carroll say, I don't want there to be a beginning. That'll be the end of science. So it seems like there's like more personal bias in there than there is scientific, observation.
And Sean's made it very clear that he takes an atheistic worldview perspective, and he acknowledges that the universe has a beginning. That doesn't go very well with an atheistic worldview perspective. And, he flat out admits that his whole research efforts is focused on trying to find loopholes around a theistic conclusion for the universe. And he says, I could be wrong. I mean, I do appreciate that he's humble enough to say, you know what, I could be wrong in all this, but as an atheist, I'm committed to do everything I can to sustain my atheistic worldview. But if I'm wrong, I'm wrong. And what I notice about my astronomy peers, they're very active in challenging the mainstream ideas in astrophysics. So they're basically looking at every possible fringe idea, if for no other reason, to strengthen the evidence for the mainstream conclusion. But yeah, if you look at the history of the past 80 years, the evidence for Big Bang cosmology has gotten progressively stronger and stronger, and that continues to this day. And if you want a percentage, I'd say it's 99.9% of the astronomy and physics community says, yeah, the Big Bang really is the way it's happening. There really is a beginning to the universe. And, in terms of these speculations, I appreciate too what Roger Penrose over at Cambridge University said. He says these speculations all presume that we got a collapsing geometry universe that perfectly joins with an expanding geometry universe 13.8 billion years ago. But just like it's impossible to take the cosmic or the singularity of one black hole and perfectly join it to another black hole and make a wormhole, mathematically it's possible, physically it's impossible, because the probability is zero that you can get the two to match. Likewise, Penrose says you got the same problem trying to join the geometry of a past collapsing universe to the geometry of a presently expanding universe. Mathematically it's conceivable, but the physical probability is zero.
Awesome. So just switching gears, I'm about to hand it over to my co-host here, David. He had some questions for you. So, David?
Yeah.
I'll let you introduce yourself there. Say whatever you need.
Well, sure. The audience knows me, and of course, just follow off of what David Russell said before. Dr. Ross, you have also had a big impact on my faith. I used to be in the young Earth creationist movement, and as I was kind of leaving that, but not really sure where to go from there, is when I came across your work. I remember I was on my break at work, and I was just going through YouTube, and I found a lecture of yours, and I listened to about as much of it as I could, and I was so impressed with how knowledgeable you were and how well you presented, and again, your humility really stuck out as well, as David had mentioned. And with about like the last 3-4 minutes of my break, I went online and I bought like 6 or 7 of your books because I was like, all right, I have to check this guy out. And I've just loved how knowledgeable you are and how humble you are. And so I do, want to thank you for all the work that you have done for the Lord, and that has been a blessing to me.
Well, thank you. And, I was a Christian 9 years before I met anybody that believed that the universe and the earth were only like 10,000 years old or less. And when I first met these folks, I thought, well, they're asking me about the age of the universe. I says, well, I believe that the universe is young. I believe it's only billions of years old, because I was so naive to think that they were referring to a debate in the first half of the 20th century where we had one group of astronomers arguing that the universe was about a quadrillion years old, and another group saying it was only billions of years old. So I said, yeah, I'm in the young universe camp. I believe it's only billions of years old, and kind of told them the story. And then I was really flummoxed when I realized, oh no, they're not talking billions. They want only thousands. So that was my introduction to the young earth argument. Being an astronomy buff, I thought they were referring to something completely different. But I had a chance to explain to them the rationale for this big debate that happened before we understand the nucleosynthesis that's going on in stars. So we really didn't know how long stars could burn. But those who are pushing for a quadrillion years were well aware if it's only billions, we can't sustain a naturalistic model for the origin and history of life on Earth. We need way more time. And so that's why they were pushing for trillions and quadrillions of years. But as you're probably well aware, the evidence in astronomy is overwhelming. The universe is young. It's only 14 billion years old. And if that's too bad for the naturalists and biology, then so be it.
So it is, yes, and I completely agree. In fact, I think you recounted that story or a similar story to that in your book, A Matter of Days, if I'm not mistaken. And so, yeah.
Second edition, you're right.
Yeah, so I just wanted to transfer a little bit here from astronomy over to biology. And I know that's not exactly like, that's not where you do as much of your research, but you've done a lot of books and stuff over in biology as well. And so I just wanted to hit you with a few questions from that field. I was reading a book last year called Darwin's Doubt by Stephen Meyer, and he raised the argument that the Cambrian explosion raises a really big problem for the theory of evolution. And I've heard you comment on this in the past, so I just wanted to, hear how big of a problem is the Cambrian explosion for the theory of evolution?
Well, it's a lot bigger than what Steve was able to put in that book because of new discoveries. And these new discoveries are basically showing the significance of oxygenation events in Earth's history. I mean, there's a good reason why you only have microbes for the first 3 billion years of life on planet Earth. The oxygen content is too low to support anything other than microbes. But there's an event that happened 580 million years ago where the oxygen content in Earth's atmosphere suddenly jumped from less than 1% up to 8%. The moment it hit 8%, you got these abalone animals. These are animals up to 2 meters across that are filling the oceans. They're animals that don't have backbones or circulatory systems or digestive tracts or brains or eyes, because there's not enough oxygen to support animals of that complexity. But nevertheless, the oceans are filled with these big animals, and they come out of nowhere. There's no evolutionary history. The instant that the oxygen jumps up to that level, immediately these animals proliferate the world's oceans. They suffer an extinction event, and is driven by another oxygenation where the oxygen jumps from 8% to 10%, and that happened 543 million years ago. The moment it hit 10%, immediately you got these Cambrian animals. And these are animals with circulatory systems, digestive tracts. They got eyes, they got brains, they got hearts. And matter of fact, you see way more complex phyla back then than we have on Earth today. Over 50 phyla show up all at once. And a phyla basically means you've got a fundamental body plan. To give you an example, all vertebrates are part of the chordate phyla. Matter of fact, you've got some animals that don't have backbones but have a spinal column. They're also part of the chordates. They're fully there at the base of the Cambrian explosion. Even vertebrates show up at the base of the Cambrian explosion. And you even got people like Richard Dawkins saying these Cambrian animals come out of nowhere with no evolutionary history. But I think what really nails down that God's got to be behind this is that the moment the oxygen jumps up to the minimum level that can sustain these animals, you see them immediately without a time delay, and you see them in great diversity and abundance. And moreover, these animals show up in a manner that's exactly what you need to compensate for the brightening of the sun. Now, the sun gets brighter and brighter over the history of life on planet Earth, and it takes life to regulate the greenhouse gases in the atmosphere. So as the sun gets progressively brighter and brighter, these greenhouse gases become less and less abundant in the Earth's atmosphere, so our atmosphere traps progressively less and less heat, keeping the temperature of the surface of the Earth optimal throughout 3.8 billion years for life to exist. And if that weren't the case, there'd be no humans and no human civilization. For us to have civilization, we need 3.8 billion years of biodeposits in the crust of the Earth. And so it means we have to be compensating for the sun's luminosity for that length of a period of time.
Wow, yeah, that is truly amazing. Especially, I didn't know the fact about the oxygen leaps, because that really seems to rule out the idea that there could be, fossil or even any sort of precursors to these animals, and that we just haven't found them or don't have evidence for them. Because it seems to me what you're saying is because of the oxygen level rising, and then the animals coming as soon as they do. There's not even an opportunity for these creatures to be there.
Yeah, and that's based on the fossil evidence. You will see claims in the scientific literature that we got animals before the Avalon event, but it's based on molecular clocks. And those clocks can be off by a factor of plus or minus 500 million years. So if you really trust the fossils, yeah, it does show. And this is all documented in my book, Improbable Planet. And I also give quotes from the leading evolutionary biologists that have studied the Cambrian explosion, where they all agree is we're not coming up with a materialistic explanation for this. And the more we learn, the more challenging it is to even speculate about that.
Yeah, super. All right, so then what about another argument that we hear sometimes for common descent? This idea of nested homologies. This seems to be a little bit more sophisticated than just, we hear the typical homology argument, which, has like the bat wing and the horse leg and the human arm and the dolphin flipper, and they're like, yeah, look, we got a similar structure here. And we've kind of, that one's been sort of easy to say, well, that doesn't imply common descent, because we could explain that by intelligent agents, beings using similar design plans. But what about when they add this idea of nested homologies? Maybe explain what a nested homology is, and then why that wouldn't support common descent.
Well, I'll go straight away to the long-term evolution experiment that's being conducted at Michigan State University. It's now almost 30 years in progress, maybe a little more than 30. And this is where they're trying to test the idea. When we look at evolution, does it go in a random way where we don't get repeated outcomes, or do we get repeated outcomes? And so they took E. coli bacteria and separated it into 12 different populations, and they put it under very severe laboratory controls, because E. coli consumes sugar for its energy process, but they knew ahead of time that it had the biochemical machinery inside the bacteria to also metabolize citrate, but not at high a level of efficiency as the sugar. And so what they did is they gave the bacteria a starvation diet of the sugar, and they gave it a huge abundance of citrate. Knowing ahead of time they only needed 3 mutations in the pore structure of the E. coli so for it to be able to bring in citrate and be able to metabolize it. And it took over 20,000 generations before one of the 12 populations evolved the capacity to metabolize citrate based on what happened to the pore structures. But as of this time, it's the only population that has. The other 11 haven't. So it's showing that evolution doesn't repeat. basically proving what Stephen Gould said many years ago, that if you were to wind the clock of life backwards and let it run again, you would get completely different results, based on the idea that there's no control, there's no mind, and so evolution is going to run with mutations, natural selection, and gene exchange, and this is bound to give you a different outcome. These experiments are basically proving what Stephen Gould said, is that you don't get repeated outcomes. And even with that one population, what they did is they went back 2,000 or 3,000 generations, because what was elegant about the experiment, every 500 generations, they took a subsample and put it in cold storage, where they basically stopped the reproduction, but actually kept it alive, so that when they got the result they were looking for, they could go back 500 generations and see if they could get it to repeat, or go back 1,000, or go back 2,000. They were able to get it to repeat if they went back 500, 1,000, or 2,000, but if they went back 5,000, nothing happened. So they basically published their paper saying Stephen Gould is right. But here's a challenge to the evolutionary paradigm. In the world of nature, we see thousands of repeated outcomes, and we especially see them for outcomes that evolution tells us they're not related. And my colleague Fazal Rana, our staff biochemist here, he's written numerous articles and books on, quote, what's called repeated evolution, or what he calls repeated design outcomes. Probably one of the more spectacular examples is what you see in the sand lance fish and the chameleon. One's a fish that lives at the bottom of the ocean floor. The other one is a reptile that lives in the desert, but they got the identical tongue and eye designs that are unique. I mean, both species, the eyes move independent of one another so that they can target a fish going by or a flying insect. Each one of them has got a spring-loaded tongue. So once they get a good track with their separate moving eyes, they can lash out with a tongue and pull the prey inward. The eyes are actually have the same protective membrane that allows them to be able to function for a long period of time. Identical designs that you see in two creatures that are totally unrelated to one another in any evolutionary paradigm. And this is not the only example. There are thousands of examples. So we're arguing at reasons to believe this is evidence for repeated optimal designs. The creator, knowing what's good for the chameleon, puts the same design in this fish that feeds at the bottom of the ocean. Totally different environment, completely unrelated to one another from an evolutionary perspective, but both of them have the optimal design for what they're having to deal with in their environment.
Wow, yeah, that is awesome. And what you were talking about with the bacteria, that would seem to kind of refute process structuralism or structuralist theories of evolution too, right? Because they basically think if you wind the clock back, it would all happen the same way. But what you're saying is that won't happen. So that seems really interesting to me.
Yeah, that Gould was an atheist evolutionary biologist, but he realized these mechanisms are going to be producing random outcomes. There's no way they're going to repeat. And basically he's been proven correct. However, a number of evolutionary biologists say we see repeated outcomes somewhere. Something must be causing them. But here's what they're overlooking. For 6 days, God creates. On the 7th day, he stops. Since God is not creating or designing these features today in the world of biology, all you're seeing is a natural process. And the natural process tells you you don't get repeated outcomes. But we see thousands of them in the fossil record, and thousands of them manifest in life that's here on planet Earth today. But that's what God did during the 6 days before he created human beings. There he was active, creating new species and putting these design features in. But you'd expect from a biblical perspective that an optimal design in one species is going to be repeated over and over again by a God. I mean, the eyes that we have. I mean, what's interesting is every eye design we see on planet Earth today was, excuse me, was present 543 million years ago at the base of the Cambrian explosion. So, the optimal designs have been there. They haven't evolved. They were there at the beginning.
Wow, that is too cool. All right, so then third argument sometimes that we hear, and this isn't necessarily for universal common descent, but certainly for ape-human common descent, so that, you know, the two are related. We hear this idea of like pseudogenes, and that they have, you know, very similar, I've heard claims up to 99% similar in their DNA and stuff. But I particularly find the pseudogene argument interesting because this would constitute evidence of a shared loss of function. We could always, you know, posit that a shared function was something that was due to a similar design plan, but it would seem that if we're having similar loss of function, that would seem to constitute strong evidence for common descent. So what are your thoughts on that?
Well, we address that in detail in our book, Who is Adam? In fact, we address a whole range of what they've been presumed to be examples of mutations, deleterious mutations that got absorbed. And the way you resolve that is to look a little broader for the designs. I mean, probably the most common example that is cited is that both we and the apes have lost our ability to synthesize vitamin C. That's a shared pseudogene that we have. But we now recognize that that's not a failed gene, that's a very optimal gene, is that we humans and the apes are able to maintain high brain function because we don't synthesize vitamin C. We recirculate the vitamin C. And the problem if you've got, say, a primate that's living a long time with a highly functional brain, if you have the creature manufacturing its own vitamin C and circulating it throughout the system, you need huge quantities of vitamin C. And those huge quantities of vitamin C will damage a brain, a large, high-functioning brain, if that's a creature that can live 10, 20, 30, 40, or 70 years. You're talking a creature that can live only a couple of years, no big deal. And so it's actually a far superior design that we have humans and these great apes that don't make their own vitamin C, but they got built within them the genes that efficiently recycle small amounts of the vitamin C. And the design we see in that recycling system is far superior to the design we see in animals that manufacture their own vitamin C. So what we thought was a bad design actually turns out to be a very good design. And we see this throughout biology. I mean, I'm old enough to realize that when I was a child, if you had an abdominal surgery, they automatically removed your appendix because they thought that if the appendix had function, it had to be in the digestive system because that's where it's located in the body. We now realize that the appendix serves a function not for digestion, but for the immune response system. So no longer do surgeons routinely take out your appendix when you got abdominal surgery. And what they used to think was a useless organ that needed to be thrown away, they now realize has a function they weren't looking for. And so that's something we've already emphasized in our book, Who is Adam? Before you say this is a bad gene or a failed design, look a little broader for design purposes you may be overlooking. And that's been ubiquitously the case. I remember when they thought 98% of our genome was junk, we're now realizing that over 90% of it serves function, and now we're looking at the remaining 10% for functions that we had missed in the first place.
Oh wow, yeah, that definitely puts a new perspective on it. That is very cool. So then just one final argument that I'll hit here for common descent that we hear sometimes comes from this idea of biogeography, and that's probably not a really familiar concept to most people. So maybe it's like a brief explanation of what biogeography is, why people think it supports the theory of evolution, and then, you know, why you think that that's not correct.
Well, I'm going to put that back on you because I've heard many different definitions of biogeography. Which one are you referring to?
Okay, so the one that I've heard is it's like a study of patterns of how animals have dispersed over the earth throughout history. If I'm remembering correctly, that was the definition I read.
Yeah, I think what you're referring to is looking at the geographical placement of plants and animals in the context of plate tectonics. So, for example, we see similar life forms on the west coast of Africa that we see on the east coast of South America. And you can date back the lineage, and it dates back to a time when Africa and South America were joined together. And so basically saying this is a region that got separated by plate tectonics, and that explains why we have those species of life there. And they try to claim that therefore these creatures have this common descent to ancestors that existed at the time when those continental boundaries were actually joining one another. But again, that could just as well fit a common design model. I mean, what's going to be optimal in that part of South America could also be optimal for that part in the jungles of Africa. So we shouldn't be surprised that we're seeing similar creatures in the Amazon that we see in the Congo.
Awesome. All right. Well, that was that concluded my question. So I'm going to turn it back over to Russell.
All right. Well, Hugh, we got about 10 minutes here. We got about 10 minutes left. I was wondering, maybe how do you think the Christian should respond to a lot of these questions? What would your advice be on that, especially ones that don't know a lot?
Well, I run a class for skeptics in my church. It's at paradoxes.org. And we get a lot of atheists that come and a lot of Christian skeptics too. And often when they raise these questions, they say, I think this is a great opportunity for a study. So I'll kind of guide them along into the research papers they should look at, the books that they should look at, and say, why don't the four of you raising this question do this study and come back with what you think is the best answer? I mean, I already have the answer, but I want them to discover it on their own. Because if they discover it on their own, they're going to own it. They're going to get a big thrill out of it, and they're going to especially enjoy sharing it with others. And it's getting them involved and basically saying, look, you really don't need me. We got all these resources you can tap into, and you can find out for yourself. And hey, we don't know. There's always opportunities to dig in. And by the way, we may not know right away. I kind of remind them of King David. God called him a man after his own heart because David would go to God with his hard questions. And he wanted answers right away, and God made him struggle. And so often in David's life, it was 10, 20 years later that he got the answer. Well, I'm old enough to realize that's happened in my life too. Questions I wanted answers to 30 years ago, I now have answers. But boy, I was kind of impatient with wanting to sit there, and God was saying, hey, you can read the literature, you can study this, you can figure it out, and if it takes you 15 years, you're going to benefit from it, and you're going to be able to share this with others. So I think all of us need to kind of look at these issues from that perspective, but recognize God gave us two books, the book of nature and the book of scripture. He's the author of the universe, he's the author of the Bible, and it's a God who it's impossible for him to lie and deceive. Therefore, this book of nature will never contradict the book of scripture. On the other hand, God's given us plenty of opportunities to dig deeper into the book of nature and the book of scripture and to discover truths that haven't been revealed to us so far. And basically he's sharing with us, it's a lot of fun to probe and dig and get answers. And so let's not lose out on the fun. And by the way, our scientists will never be unemployed. We're never going to get to a point where we say we know everything about the book of nature. And it's also true with theology. I don't think our pastors are ever going to be unemployed or our theology professors. What's unique about the Bible amongst the words holy books, it can't be exhausted. There's no way you can dig deep enough into it where you know everything it can possibly reveal. And so let's join in the fun.
Hey, I agree. I echo that. There was a time, I used to see the rings of Saturn on the TV, but there was nothing like actually finding Saturn in the night sky and seeing the rings right there themselves. I mean, it was just, there's nothing more rewarding than that. So I agree. And I echo that.
Very good.
Here's a fun one. And wanted to ask this because I got a lot of coworkers that, talk about life on other planets and this and that about, there has to be, because the universe is so big. And there's been a lot of discoveries about finding new Earth-like planets. So if you could just speak to that just a little bit, what is the deal with those new planets?
Well, I write a lot about exoplanets. You'll find many articles at today's New Reason to Believe at reasons.org. And basically making the point that astrobiologists have focused on the liquid water habitable zone, the distance from a star where a planet could possibly have liquid water on its surface. That is a requirement for life, but it's one of many requirements. The last blog I wrote on this has said we now have a list of 13 known planetary habitable zones. And for a planet to be truly habitable, it must simultaneously reside in all 13 of those zones. We know of only one planet that resides in 3 or more of those planetary habitable zones simultaneously. And you get 3 guesses as to which that planet is.
Yeah, I found that was really cool. Like when they first came out with these planets, NASA was putting it on their website. CNN was talking about it. Time was talking about it. And we're finding all these new planets all the time. And then I read one of your articles, and it was like, okay, well, it can't be between this and it's circling around a red dwarf. And I'm like, okay, that explains it. And it made sense. It's like they're trying to trick us almost, or either that or they're just getting into the hype of it.
Yeah, well, I said most of the focus is on the liquid water habitable zone.
Yeah.
But the other one that's well known is called the ultraviolet habitable zone. And where only a tiny percentage of stars does the ultraviolet habitable zone overlap the liquid water habitable zone. The planet has to be orbiting a star exactly the mass of the sun. If the star is more massive or less massive, those 2 zones will not overlap. And then you got 11 other zones that got to overlap. And so, yes, there are tens of billions of planets in our galaxy, but we're orbiting the one planet on which advanced life is possible. But I've been on record, public record, since the 1980s. We will find the remains of life on the moon and on Mars, and look hard enough on every solar system body. The reason why is Earth has been so abundant with life for such a long period of time. Meteoritic bombardments of the Earth have caused bacteria and microbes to be exported throughout the solar system. And we're talking a huge amount. 20,000 kilograms of Earth's soil exist in every 100 square kilometers of the moon. And if we go back to the moon, we will find the fossils of Earth's first life. And I'm excited about that because non-theists and theists have got very different predictions on what those first fossils will look like. We can go to the moon, uncover those fossils, and see who got it right. I actually had the privilege of speaking at NASA Houston on this and saying, we need to go back to the moon with a different mission, not to find pristine lunar rocks, but to find that Earth transported soil and see who got it right, the atheists or the theists. And last time I checked, those 2 people groups made up 100% of the taxpayer base of American citizens. And so everybody should be excited about seeing who got it right. We can do the same thing on Mars, but it's going to be a lot more money because there's only 200 kilograms for every 100 square kilometers on the surface of Mars. The moon's the best place to go to find that. On the other hand, I'm confident bacteria and microbes from the Earth will not survive a trip across interplanetary space. We've infected our solar system, but nowhere else. One other thing I can add about exoplanets, I remember back in 1995 where they predicted we're going to find hundreds of planets just like the planets in our solar system. We now have found 4,100 planets outside of our solar system. Guess how many match the conditions of any one of the 8 planets of our solar system?
0.
It's 0. And what that led to was the recognition. People said, we got to figure out why it's 0. And we now realize every one of the 8 planets in our solar system must be exquisitely fine-tuned to make advanced life possible here on planet Earth. We wouldn't be here if Mars wasn't exactly the way it is, or Neptune exactly the way it is. When we celebrate Thanksgiving, we thank God for all 8 planets.
Yep. It's funny. It's funny you say that because one of the answers I give the guys at work and stuff like that, they looking at me like I'm crazy when I start explaining this stuff. And I just say, you know what? The more I study this stuff, the more I'm convinced that we're the only one out here. The more I study it, the less, because I'm a big Star Trek fan too, and they know it. So it's like, it's just funny. I just tell them, and they're like blown away by it.
2 papers have been published in the last year by non-believing astronomers where they said, we think there could be advanced life in the universe, but not now. It's got to be in the future. Why? Because they calculated the minimum time you need in cosmic history to get one species of intelligent life. We're here at that minimum time. It'd be impossible to bring the equivalent of human beings on the cosmic scene in anything less than 13.8 billion years. So there may be intelligent life after us, but we're the first and we're truly alone. We want to have intelligent life, we're going to have to wait a while before they can exist anywhere else. Now, that doesn't mean there isn't bacteria on another planet, but there will not be the equivalent of human beings. So yeah, they need to rewrite all those Star Wars scripts. And by the way, there is no galaxy far, far away. The only galaxy that meets the qualifications is the one we're in.
Absolutely. Well, David,
that
had one more.
Very awesome. I did, just because I've always kind of wondered about this one, and this is, not really science related. This is more like you said, we'll never fully understand nature, and we'll never fully understand scripture because we can just keep learning from it. But this is a little bit more of a scriptural question, and just one I've always wondered about because I don't think I've ever seen you directly speak to it. But because we talk about Calvinism and stuff a lot on this show, I was just curious, what is your opinion on the whole issues of predestination and that debate?
Well, I'm actually giving that chapter away. One of the books I've written is called Beyond the Cosmos. And if you go to reasons.org/Ross, I'm giving away the chapter where I show you how you can reconcile human free will and divine predestination in the context of many more dimensions of space and time. I mean, the space-time theorems prove that God can create space-time dimensions at will. And so what I do in the book is show you, hey, if we simply allow God to be as big as what physics now proves, there's multiple ways that you can have human free will simultaneously operating with divine predestination. It doesn't work in a single dimension of time, but if you allow for geometric time, there's many ways you can make it work. I give you 3 examples. And yeah, the chapter's free. Incidentally, you can get free chapters of all my books by going to reasons.org/Ross. But yeah, your question, chapter 13 of that book, and you can get it for free.
Awesome. Thank you so much.
That's awesome. Well, Hugh, we're at the end of our time with you today. Again, thank you so much for coming on. And I know I've really enjoyed this. What about you, David? Absolutely.
I have thoroughly enjoyed it.
Yeah, me
awesome.
Just you ask questions.
Okay. Thank you.
Very often, so thank you.
Absolutely. Maybe you could come on again, and so we can pick your brain some more.
Well, if you come up with more hardball questions like this, that would be really fun.
Okay. Awesome. Thank you, Hugh, so much. I'm gonna tell everybody to go to reasons.org to find Dr. Ross and his team there. We support him. I have many of his books. Go on there, check them out, and tell me what you guys think. Thank you, Mr. Ross.
You're very welcome. My pleasure.
Interested in growing your ancient language skills but not sure where to start? Glossa House can help. From illustrated readers and short stories to lexicons and grammars, Glossa House offers a variety of resources for beginning, intermediate, and experienced ancient language learners. Head to glossahouse.com today. Glossa House, language resources for the global community.